I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, Data Warehousing Enhancements in Microsoft SQL Server 2008. Now it is my pleasure to introduce today's presenter, Torsten Grobs, who's a Senior Program Manager with Microsoft. Torsten, you now have the floor.
Thank you, Heather. Welcome everybody to today's webcast. It's a pleasure to have you around today. And as Heather indicated, I'm going to cover data warehousing enhancements for the upcoming SQL Server release in the following 15 minutes. My role as a program manager is to oversee developments in the area of query processing in the SQL Server engine. And I've been involved in a number of features for SQL Server 2008, most notably the star join feature, which is part of the data warehousing enhancements, and other features related to query processing and query optimization. Let me switch over to the following slide. In the next 60 minutes, what I plan to do is to give you an overview of the SQL Server enhancements for the upcoming release that are targeted specifically at data warehousing scenarios. After the presentation, you should have an idea of the performance characteristics of the upcoming release when you're using it or planning to deploy it in a data warehousing setting. And I also encourage you to have a look at the Community Technology Preview, or CTPs, where a number of the features that I'm going to talk about today are already exposed, and you can download the CTP and try out how those features work for you. And I'm particularly interested in hearing feedback from the experiences that you make when you try the CTPs. From a 10,000 feet perspective, let me start by that to give you an overview of what we are planning to do for SQL Server 2008. You should expect to see improvements across the box. That means across the whole SQL Server product. That means we are planning to make enhancements to all the major pieces, including integration services, the relational database engine, analysis services, and reporting services. The improvements are with a focus on performance and scalability throughout the whole product. And just to make this more tangible for you, we have a large testing effort on a high-end machine at Microsoft in the SQL Server team, where we try to test a large-scale customer-driven configuration and really hit the limits on that box and make sure that our features that we develop work well. So to give you an idea, the database engine testing that we perform in that infrastructure aims to cover 100 billion fact table rows on a 32-core machine. On the analysis services side of things, we are looking into 25 billion fact table rows on a 16-core hardware. And part of that is, of course, to see how things scale as the fact table sizes increase for you, or as you're adding additional cores to your machine. And we want to make sure that these things work well for you. And that's also a very important point for us in SQL Server 2008, to really make sure that things work on the high end. So let me drill a little bit deeper into the actual enhancements that we did to the product, and I'd like to structure this into three big pillars that you see on the slide on the screen. The first pillar is extract, transform, and load ETL. The second one is query and analysis, and the third one is administration and manageability. And I'll go through all these three pillars in the next couple of minutes during the presentation and highlight the most important enhancements in each such pillar. So let me get started by looking into the first pillar, the extract, transform, and load enhancements. There, I already have a list of the features at the bottom of the slide. So we're going to cover merge, minimal logging, insert over DML, change data capture, and so forth. And all of these features are covered by subsequent slides. So let me go ahead and get started with merge functionality. Merge is syntax that the SQL standard already exposes, and it can be used to combine multiple data management operations into a single statement. and it's also known under the name of upsert. So, and if you speak of upsert, it's more intuitive to see what it actually does. So it combines an insert and an update into one SQL statement, and it's very useful in a data warehousing context as a building block for more efficient ETL, because oftentimes during ETL, folks need to either update an existing record, or if the record is not yet present, insert it. And we have added support in Transact SQL for the merge statement, and our implementation is actually compliant with the SQL standards. So let me give you an overview of what the merge statement does for you. So think of a source table that can either be a table or actually a query that holds a number of records, and a target table or an updatable view that again has a certain number of records. And so what the merge statement can do for you, it can compare the source against the target, and if the records match, then the statement performs an update of those records. And this is what you see on the slide. So the red records are the ones that match, and what the merge statement does for you for those records is it performs an update depending on what the source says. Let me move to the next slide. So if there is no match, and this is what I try to indicate by those black or gray records, then the merge statement performs an insert. So all the grayed out statements, the grayed out records from the source are taken over into the target table and inserted as new records into the target. Well, last but not least, what happens to those records that are present in the target table but not present in the source table? There you have the option to also perform a deletion operation on those. And this is what I try to indicate with the green row that you saw in the target table, which was not present in the source. And this is a record that got deleted in my particular example here. So to make this more actionable for you, let me present you a little example using the actual merge syntax as we have it in SQL Server. This example shows a merge statement against a stock table, and the stock is the target table, while the trades table is the source table. And what we want to do with that statement is basically take the daily trades and have them be reflected in the underlying stock table. And this is what the merge statement here does. So it compares the records that are present in the stock table against the keys that come from the trades table. This is what you see in the on clause of the statement. And then it has matching match clauses for deletion, update, and insert. And you see if that in the first clause, if we reach a stock of 0, then we go ahead and delete that record. When we have a match that does not get us to 0 stock, then we are performing an update by bumping up the quantity in stock by the delta that comes from the trades. And last but not least, the last when not matched clause then inserts the value if we have no match on the target side. There is an interesting aspect of the merge statement, and it can actually come, this is basically the same statement that I had on the previous slide, what you see right now. It can come with an output clause that allows you to look into what actions were performed and to look into the data values that were shuffled around. This is highly valuable in contexts where you need to do logging or auditing. You can take this output and, for instance, insert it into an auditing table. This is something that I'm going to cover a couple of slides down the road, but I just wanted to highlight that functionality already in the context of the merge statement. So let me move on to another enhancements that we have in the product coming up for SQL 2008, and this is logging enhancements. And it's targeted at in improving our performance for insert statements, and to make sure that we only log what is absolutely necessary to roll back an insertion operation. And just to point out some of the technical basics here that we rely on for inserts, it's sufficient to just log the page allocations, because if you know which pages you allocated and you inserted to, you already know how to do the to perform the undo operations by just deleting the pages that you just allocated. And we are taking advantage of that observation in this new logging enhancement. So something to note in that context is to benefit from that new feature, you need to use a recovery model of simple or bulk logs. And in previous releases, you already get similar functionality, similar performance for create index, select into, or actually bulk copy insertions. But in this release, we are making it available, the same performance for regular insert into statements. And the performance boost that you should expect to see when using that is a factor of 3 to 5. And I have a little chart here that tries to give you an idea. So if you're inserting into a plain table, into a heap, and compared to previous SQL Server versions, previous releases, then you should get down from the blue column to the green one in SQL 2008 when you're looking into runtime. And there's very much a similar picture for inserting into an index in terms of runtime. So this is very nice because it helps you achieve your service level agreements for the data warehouse maintenance window, because your insertion operations will benefit from that improvement and should complete in much shorter wall clock time. Another area of improvement in the product is insert over DML. I already touched that area briefly when we were discussing the merge statement. What this feature as a whole, but just beyond merge, gives you is the ability to have an insert statement perform on top of whatever DML you want to do. And this is exposed to the output into clause. And it comes with optional additional where clauses that you can use to filter the results as it comes back from your DML. The functionality in the where clause is somewhat limited, so you can only get access in predicates in the where clause to the actual values and the rows that are returned from the DML, so you cannot perform any subqueries or data accessing UDS or any full text operations. Use cases for that functionality are, as I already mentioned in the context of merge, is track history of slowly changing dimensions, or to do audit logs where you dump the delta stream that comes from the DML into a secondary table, and someone is going to look over this secondary table in a post-processing step. Here is an example. So it has nested into the overall statement a merge statement that goes against the book table and tries to merge the weekly changes into that book table. And you see two clauses, two when clauses, when matched and when not matched, that either perform an update or an insert that's fairly straightforward. The interesting part is the output clause that you see down there. So we are outputting the actual action that was performed on our books table. We are also outputting the ISBN number and the price of the book that was deleted, and the shelf column of the book that was deleted. And then we are selecting this information. We are augmenting it with a get date call. And then we're taking this and we are inserting it into the books table and now put in an end valid date to that book. And that gives you basically a slowly changing books dimension where we keep track of for what period of time has a certain record in that book table been valid. This is very easy to do now with the functionality that I have on this slide, the insert over DML, where you can look into the changes that were actually performed and then insert them in some place. Let me move into another area, another important feature that is also very much related to the requirements around auditing and logging. And it is called change data capture, and it's an easy mechanism to track changes on a table. And what the feature does is it basically captures the changes from the log in an asynchronous fashion, and it shows you what has changed at the source table and exposes that information through a set of table valued functions. And it's very easy to be consumed from integration services. And I have a little example down here that basically shows you what's going on. So think of some source table that holds a number of records. Updates are going to work against the source table. And as the updates commit, the transaction log is maintained. And as the little figure shows, you have a capture process that consumes the changes that go into the transaction log and exposes them in the change table, which can then be further post-processed through the change data capture functions. So if we move to on the next slide, I have a number of those new functions that and stored procedures that we expose to make use of the feature. So the first two, the SP to enable a change data capture on a certain database is the first one that you see on the slide. The second one is to enable change data capture on a specific table within a certain database. So these are basically the two main stored procedures that you would use to switch on change data capture functionality for a certain database and a given table. The next question then, of course, is how do you consume the information about the changes? And this is the second set of functions that I have on the slide. So you see functions to get all changes or to get net changes. So these are the interfaces. This is the surface area that you would use to actually look into the changes that were performed on the source tables that you were monitoring. Another important area is lookup in SQL Server integration services, and we have performed a number of improvements on that front. And the main problems there that customers hit were basically that the initialization process for a lookup operation in SSIS took longer than the actual maintenance of the table, or that folks ran into problems with the cache size. And in 2008, we are planning to improve on that. And the main improvement is that we now allow to persist the reference tables. You can keep them on your local disk. So anytime you need to do this lookup operation, you don't have to go back to the original table. You can rely on what you have already persisted on your local disk. So you don't need to touch the actual database to perform the lookup operation and figure out how, for instance, business keys in your records map to surrogate keys, so that you can then, in the following step, insert them into the fact table. A further improvement that is on the database engine side of things is data compression. The main goal there is to shrink data warehouse fact tables, and only a secondary goal is to improve query performance. And the data compression functionality comes in a number of different flavors that I'm going to cover on the next couple of slides. But keep in mind that it can be enabled on a per table or index basis. And if you're using compression, that you're facing a trade-off between storage savings and CPU usage increases. So that's because if we fetch a row from a compressed table or index, it needs to be uncompressed, and there is some overhead to do that on the CPU side. So let me quickly walk you through the technology for data compression. Think of the table that you see on the slide. Comes with 4 columns: date ID, carrier tracking, offer ID, and price discount. And what SQL Server 2005 in Service Pack 2 already gives you is a var decimal data type that enables you to store decimal values as variable length data. And this is what this slide illustrates. It takes the 4-column table, and the little blue boxes indicate how much storage is being used. And if you look into the price discount column of the table, you see that in the original table, every price discount, be it a 0 value or the value 100 in the second last row, take up the identical amount of storage. And if you change the data type to var decimal, they will take up different amounts of storage, so the 0-based will be much more efficient to be stored than the 100 value in the second to last row. So this already gives quite some improvement if you are using decimal data types, and it comes with, as I mentioned, SQL 2005 Service Pack 2. Now looking forward into SQL 2008, it extends the variable storage scheme that we have just seen to other data types that are usually fixed length, like integers, big integers. And this is what I tried to illustrate in the third column, the offer ID column. Originally, all of those columns would basically take the whole space that is needed to represent all the values up to the maximum integer value, or whatever the maximum value is in the domain that you're using. Now with SQL Server 2008, you make this a variable storage format, and so for instance, if you're using small values like 10, you will see a decrease in the storage requirements for that column, and you will get savings from that. So this is one of the aspects that we are adding to 2008. There are others, like prefix compression. So a prefix list is stored on the page, on each data page, and it holds the common prefixes for values that occur on that page. And now taking this list, we are in a position to replace the individual values in the records by tokens that point us back to the prefixes, and suffixes that when you add them to the prefix make up for the whole value. And I again tried to illustrate this with my little example table. And if you look into the two columns, the date ID and the carrier tracking column, you can see how this would work. So the prefix list is the green area on top of the page, and it holds 3 different prefixes that you see that are indicated by the tokens 1, 2, and 3. And you see that for the date ID, we can use the prefix 1 throughout all the values that we have in the table, and we just add a suffix 1 or 2 or 3 depending on what value lives in the record. In the second column, we have a similar scheme. So we take the prefix that goes by tokens 2 and 3, and we store the token, and the suffix 8, 9, 3, 4, and 5 tell us how to get from the token to the original value. Note that there is an interesting difference for the third row in the table, where we only have 4 digits out of the whole prefix. And there's also a way to indicate that, and this is indicated in the figure by this little arrow that goes over the 4, and it basically tells us that taking the token and its corresponding prefix, the actual value consists only of the first 4 digits of the prefix. And yeah, this is pretty much in a nutshell how the prefix compression is going to look like and work for you in SQL 2008. And there is yet another flavor of compression that you can use, and that's called dictionary compression. And and what dictionary compression does is takes the common values that are shared among the records on the page and folds them into a dictionary. And those common values that are then represented in the dictionary can be replaced by much more storage efficient tokens in the original data that lives in the records. And how this would work for the example table that we already achieved by prefix compression in the previous step is illustrated by the 2 example tables that I have. The one on top is the one that we had on the previous slide that came out of prefix compression. And now for dictionary compression, we're going over the data in the rows, and we're figuring out what are the common values, and we take these into our dictionary, and they are represented again in the green area in the second table on the slide, and they go by the tokens 1, 2, 3, and 4. And you can see that wherever the values 1, 2, 10, or 0.00 appear in the original data on the page, they have been replaced by pointers to the token into the dictionary. Now this is great because it gives you real savings. So what we have seen for real data warehouse fact tables in our in-house scenario-based testing, where compression ratio is up to a factor of 7. And well, it depends on your data, of course, how much compression you're actually going to see if you deploy that feature, because well, you might have different degrees of redundancy in your data, and that pretty much defines how much you can do by using compression to get your storage requirements down. So this is an interesting feature, the data compression, but let's move ahead into a functionality that we have on the analysis services side of things that is already available in the June CTP. And this is very nifty enhancements to the designer that comes with analysis services. And what we try to do is, based on the feedback that we've got and the best practices that we have worked out together with our customers, we tried to put this information into the designer, which should help you at design time to already be aware of best practices and to keep them in mind in order to make sure that you have a good and well-working design. So what you can see now, if you fire up the designer, is that if you work, there will be hints that show up. It's barely readable at the bottom. So let me go back. So if you look into the screenshot that I have at the bottom, and you will see now as I go forward that if you're working, you will see hints like the one that just showed up appear on your screen in the designer. So this one basically encourages you to fold two measure groups together because they share the same dimensionality. So this is just an example of the best practices and guidance that you will see now pop up as you go and work with the analysis services designer. And it's very useful because it prevents you from running into traps later on that are due to a design that is not according to best practices. So this covers the first area that I was planning to go through today, the first pillar that was around ETL. I'd like to move forward into the second pillar at this point, which is around query and analysis, and discuss the enhancements that we have made in that area. And I plan to spend most of my time on parallelism for partition tables and star join processing. And let me go ahead and get started with partition table parallelism. What you see on this slide is an order table that is partitioned on a weekly basis on order date. And things that the customers have experienced is that if you run a certain report on a Monday morning, things work fine, you get great response time. But if you do it again on Tuesday, for some reason, the response time is much poorer as compared to Monday. The reason why this is happening is for the Monday report, think of the report just going against 1 week, then we're just hitting one partition out of our partition fact table. And this is a case that is very well supported by SQL 2005, and that's the reason why I see great response time in that case. Now looking into the Tuesday morning report, it might turn out that it is still against a week, but it crosses the partition boundary of weeks in the orders table. And then you're hitting a case where you're just touching two partitions, and SQL Server 2005 then allocates, if you go beyond one partition, a single thread per partition. So in this example, you will work with two threads, one thread against the first partition, another one against the second partition, and compare this to the previous case where you were basically running all CPUs of your box against a single partition. That explains why you might end up with poor response times in those cases. And we are trying to address this in SQL 2008. And the way we are planning to address this is basically fix this single thread per partition problem. What happens with, starting with 2008, is that an arbitrary number of threads can go against a single partition. So you will start off basically allocating all the threads, all the GPUs of your machine against the first partition that you are touching. And as the threads proceed to the first partition and finish up the first partition, they are able to move over automatically into the second partition. So you will always get the full degree of performance on all of the partitions, and you'll basically utilize the resources of your hardware much more effectively than before. Here on this slide, I basically took two data points. One is on a somewhat mid-range machine, 4-core machine. We have a 40 gigabyte fact table with its partition by week. On one buffers, we are running a query that faces exactly the problem on 2005 that I was pointing out previously, where you hit two partitions, and most of the data lives in one partition, and just very few data is needed from the second partition. On SQL Server 2005, that query takes about 1,200 milliseconds, and if we go down to if you go to SQL 2008, it goes down to less than 400 milliseconds. So we have about a 3.5 performance improvement, and there's no change to the query. It's just change of behavior in how we deal with partitions. There's a second data point, which is a kind of worst case scenario on a 64-way box. Again, similar query, similar data set, not exactly identical. And there, in our SQL 2005 experiments, it took about 16,000 milliseconds to perform the query that again went against those two partitions. And if you go to SQL 2008, you will see performance improve to about a second, down from 16 seconds to 1 second. So that's at least an improvement of a factor of 15 that you experience here. And again, there's no change in data, no change in query, it's just change in behavior inside the SQL Server engine. So this is the first area in query processing where we're making huge improvements, partition table parallelism. The second area where you should expect to see huge performance improvements is for star join queries. And to give you an idea of what a star join query is, it's the usual decision support query that goes against the fact table and performs joins against a number of dimension tables. And the set of rows that qualify for the overall query result is usually reduced by filters against the business keys in the dimension tables. And what we're doing for non-selective queries that go against the whole fact table, where there's not much you can do, you do a table scan, and if you're using data compression, you will see those table scans speed up compared to SQL 2005. In 2005, for highly selective strategies, which are at the other end of the range, we already have query processing functionality that targets this scenario. And now talking about 2008, we have additional query plans that we added that are specifically coined as a huge range of medium selectivity queries that basically select from 10% of the rows of the fact table up to 75% of the rows of the fact table. And that's an interesting area because there are a number of different query plans is attractive to look into. And the ones that we targeted that you usually see that give you good performance out of the box are right deep hash joins that join the fact table against a number of dimensions. And so in 2005, for those medium selectivity queries, SQL Server was already in the position to add so-called bitmap filters, which implement semi-join reductions to the query plan. You see these show up as bitmap create operations in your 2005 query plan. And now with 2008, we can have multiple of those bitmap filters in the query plan that do efficient semi-join reductions. And on top of that, we are able to move those bitmap filters around quite flexibly in the query plan. And the objective is to move all those bitmap filters that were introduced by the different dimensions down to the fact table as much as we can. And when we have all those bitmap filters for all the dimensions down there sitting on top of the fact table, then it's crucial to pick the most selective bitmap filter first to eliminate rows early on that flow from the fact table upwards in the query plan. And this is what we achieve by adding reordering functionality to the product, so we can now dynamically at runtime reorder those bitmap filters. And here are some results that I want to share with you. You see 3 different charts on that slide, and they come from 3 different customer workloads that we looked into when we were developing the feature. And the main idea of those charts is basically to show you which part of the query workload ended up getting faster and which ones did get slower. And the main takeaway from that slide is you see a lot of those queries in the workloads end up in the green buckets in the charts. And this is what we were looking for, to make sure that as many queries as possible benefit from these performance improvements that I was just discussing on the previous slides. And on the flip side to it, very few queries only end up in the red parts where performance got slower for whatever reason. So, and what you see is that query response times across the board for the project real workload, just to take one example, improved by 17%. If we also took a snapshot of the TPCDS benchmark that is not yet finalized, but we took a snapshot of that workload, query response times there for individual queries improved by 23%. And also we took a snapshot of our in-house sales data warehouse, and there we saw an overall improvement in wall clock response time for the whole workload that these folks need to run by 18%. Also some encouraging numbers from a customer lab deployment where a query was problematic because it took more than 1 hour on SQL 2005. Manual tuning by the experts brought the query response time down to 55 seconds in the lab. And then we went ahead, this was in 2005 still, then we went ahead and actually deployed SQL 2008, and out of the box, without any manual tuning, the original query as it stood improved to 35 seconds, down from basically 1 hour. So I have a little demo that I'd like to share with you at this point around star joins. So let me switch over into SQL Server Management Studio. And what I have here is a straightforward copy. It should look familiar for you. If you look into the Object Explorer, I have AdventureWorks DW. I simply took a copy of AdventureWorks DW star join because I want to fool around a little bit with the main fact table in AdventureWorks. So let's clean up a little bit. And what I do here is basically take whatever we have in the fact internet sales table, which is the main fact table in AdventureWorks DW, select all this into a new fact table. And I'm doing this now basically 4 times to give us a little bit larger fact table. And now, since we have this fact table with about 240,000 rows, I'm going to run this query, which is a fairly straightforward medium selectivity decision support query. What the query does, it goes against the main fact table, this table that we just basically created, and the time dimension and the product dimension, and it looks for records that are in the calendar years 2003 and 2004, and for products that start with a prefix of DK in their alternate key. Then the query goes ahead, groups by the alternate key and the calendar year, and sums up the sales amount. So fairly straightforward query. Let's run that, and it comes back with the result. And what I want to show you is the query plans that I was talking about previously. So this is all grouping and aggregation on top of the query plan. Now if you look into the query plan down here, you see the 2 hash joins. Here's another one. And finally, the fact table down here. So we're seeing one of those right deep hash joins.
And now let me highlight those parts in the query plan where the new bitmap support kicks in. So you see a bitmap create here for one of the dimensions. And there's a second bitmap create in the query plan, which is up here. This is the second bitmap. And now these bitmaps are utilized as filters on top of the fact table, which is down here in a predicate, a probe predicate. Let me bring this up. A probe predicate against the fact table that uses the information that comes from the first bitmap and C and the second bitmap. So this shows you basically also how to make sure when a certain bitmap is being used to reduce the number of rows that come from the fact table. And this should give you great performance improvements because a lot of the rows that usually flow through a number of joins in SQL 2005 are pruned out very, very early on during query processing and don't need to go through all of these joins. Let me go back into the slide deck and highlight you some other features in other areas of the product where you should see performance improvements. This one is from Analysis Services, and it is around subspace computations that we make more efficient to improve MDX² performance. And the idea of that functionality is that usually the cubes are fairly sparse, so very few of the cells in the cubes are populated. And we want to improve on that front because, well, SQL Server 2005 goes over all the empty cells, all the empty values in the cube, and this is just unnecessary. So we are partitioning the cube into subspaces that we keep track of whether they are empty or whether they are populated. So in this example, you see that only a few cells are populated and there's huge amount of empty space. So we're taking out this empty space and we don't need to consider it for the computations there. In terms of enhancements to reporting services, we have tried to make the reporting engine much more scalable, so there's a number of enhancements in that area. Also, you don't need to rely on Microsoft Internet Information Services, IIS, any longer, no longer required. Word rendering, you can now render your reports into Word documents. We have made the report layout more flexible and also tried to enhance the data visualization part of your reports. So this pretty much concludes the third area, the second area that I wanted to go to, and I'd like to move forward into the third area that I wanted to discuss today, and that's administration and manageability features for data warehousing scenarios. And a lot of the following slides will cover improvements to backup, and I have also one very nifty feature which is called Resource Governor, that we will spend a couple of slides on. So let me get started by talking about backup compression, which is a functionality that we added to SQL Server to the database engine. And the main customer feedback on backup was that keeping the disk-based backups online is very expensive, and that backups are taking longer while maintenance windows tend to shrink. So SQL Server 2008 should take care of a lot of these pain points with a new functionality that comes with a compression clause that you can add to the backup statement. And if you do this, you require less storage to keep the backups online, and there's much fewer I/O done as part of the backup, which should make backups run much, much faster. The restore part of things automatically detects whether compression was used at backup time and adjusts accordingly. Now, talking about backup compression, which was a functionality on the SQL Server engine side of things, we are now shifting gears over into analysis services. And also in analysis services, we have made a number of enhancements to backup. The main customer feedback there was that basically the backup time grew exponentially once you went beyond 20 gigabytes for database sizes. That the implication of that was that you were fairly limited in the size of the individual database files and also the number of metadata files. In SQL 2008, we went ahead and pretty much replaced the analysis services backup storage subsystem, and now the backup times, the time that it takes to take a backup, grow linearly in the size of the database, which is what you expect. And we also, that removed the limitations on the backup size and the metadata files. And I have some numbers here to highlight this on this chart. So if you look into this chart, the x-axis of the chart shows the size of the database, while the y-axis plots the time that it takes to take the backup. And you see the light blue, you see the blue curve for 2005 backup that just goes through the roof from a certain point, and you see the other curves, which is the green one, which is the SQL 2008 curve, which is straight and linear as you like to have it, as you like to see it. And if you look into just flat file copy, what it would take, you see that there's a second curve, light blue below the green curve, which is just a plain file copy. And you see that in terms of the growth function, we are very close to just flat file copy, which is very nice. Okay, let me also talk about what I already mentioned, the resource governance feature that we added to 2008. So if you take a snapshot of SQL Server 2005, at a certain point in time, you will see in production a number of different workloads that are being performed. So there are backup and admin tasks, which go into an admin workload bucket, which is one of the blue cubes that I have on the slide. There are OLTP workloads, just transactional processing that is going on. And there are some sort of reporting, executive reports or specific reports, which go into the third area. All of these different workloads share the same pool of resources. So they share the same memory, CPU, and threads. And so if one query in one of those different workloads goes out of band and runs away, then all of the other workloads are also affected. So if there's one executive report that just takes forever, it could take over the box and affect, for instance, the backup process that is running concurrently today. So bottom line, in SQL 2005, the resource sharing and resource allocation was best effort, but you had little control over cases where you faced runaway queries and things like that. And we are trying to improve on that front in SQL 2008, and this is where the resource governor feature comes in. And the main functionality there is that it allows you to differentiate between your workloads. So you can look into the queries or the requests that come in and distinguish them by their application name or the login that performed them. And then based on that, that characterization of your workloads, you can have specific per request limits on, for instance, the memory, the CPU time, grant timeouts, the maximum number of requests, and you can also monitor what's going on. But the interesting part is when you go ahead and say, well, I have workloads that have different importance for me. For instance, you could think of the OLTP activity, the transactional line of business application that I have in this example here, as being the mission-critical workload that is highly important for your business, and you want to give a preference to resource allocations that come from that workload. And this is functionality that Resource Governor now gives you. And basically the steps that you go through are that you first say, well, I split up my resources in a number of pools, and I've done this on this slide, try to illustrate this. So now we've taken the whole shared resources and split them apart into two different pools. The first one is an admin pool, And the second one is an application pool. In the admin pool, we have certain thresholds, limitations around memory and CPU, so you can basically say that at least 10% of the system memory go into the admin pool, but a maximum of 20% can be consumed by the admin pool. Also, the maximum impact on CPU by requests that run against the admin pool should be 20%. For the application pool, in turn, we say that at most 90% of the CPU shall be consumed by applications that run in the application pool, so that we always have at least 10% of the CPU available for other tasks in the system. Now, the second aspect to it is to actually go ahead and also classify your workloads. So what you can do there is to remember the differentiation of the workloads that we have. And once you have done this, you can assign the different workloads that you came up to classify with and assign them to the different pools. So what I've done here in this example on the slide, I've taken the admin workload and I've assigned it against the resources in the admin pool. And I've taken both the OLTP workload and the reporting workload and assigned them over into the application pool resources. And that is very nifty functionality because it really gives you the ability to design with service level agreements in mind and then define your application pools and your different workloads based on the service level agreements that you have for the different workload classes. And I'd like to demo this to you in the next couple of minutes. And let me do this and take you over into SQL Server Management Studio again. And let me close down the window from the previous demo. And let me go in here, use the master database. And the first step that I'm going to do here in the demo is to set up two pools. The first pool is for slow running queries, and as we start off, they can go up to 100% CPU. And create a second pool along the same lines for fast queries. So that takes part of dividing my resources across different pools, and we will further down the road refine those GPU thresholds a little bit. And the second one here is group definitions. The group definitions are basically the workloads that you define, and we have a workload that's called group slow that uses the pool for slow queries. And we have a second workload, group gfast, that uses the pool for fast queries. And we also have a function that we need to create that classifies incoming requests into a workload group. And I create this here real quick. What it basically does, it's a function that can look into certain characteristics of the connection, like what is the username that we are coming in under. So, and if we are coming in under username 1, then we set the return value to the slow group. If we are coming in as user 2 instead, we are going against the fast group. And you can have much more refined logics in this classification function. And this classification function basically implements the mapping of your workload class against a certain pool. Let me also go ahead and create the two users that we were already using in the function and make all this live by running the auto resource governor reconfigure statement. And now I'd like to go ahead and put some load on the box. So let me switch over real quick into the performance monitor. So you see there it's fairly light load. There's some load on the system caused by live meeting at this point, but it's fairly lightly loaded. And let's go and connect against the database as user 1. And do some basically more or less unbounded loop processing here. And let's do the same thing for Before I do that, let's go over and see, yeah, you see we are hitting the system, so we are at about 50% CPU based on the loop that I just kicked off. Let's do the same for the user 2. And execute this again. So you see we're keeping the box pretty much busy. And now let me move over into the into Research Governor again. Check what's going on. And what you already see, if you look into the user sessions, you see that the 2 sessions that I just created, that I just started, are going against the slow and the fast group based on the classification function that we just implemented. And now let's assume that we are not happy with the assignment of max CPUs against those different workloads, and we want to make a change. So let's go ahead and say the slow pool can have at most 10% of the CPU, while the fast pool can have up to 90%, and make this live. Go back into performance, still maxing out the box. And now let me show you the different counters that we added. So we have workload group counters and you can add counters for the different groups. Now this is interesting. Because what we should see right now, that the fast pool takes 90% of the GPU that we are running against, while the slow pool takes only 10%. Check something here. Sure, let me go against the right guys. Okay. Give me a minute here to see those guys. Those guys are executing. One. Here's the users. Let's disconnect this one. User 2. Yeah, I somehow don't really get to the point where I can show you in the performance monitor what I would like to show you. And we are running out of time. So let me stop at this point with the demo and go back to the slides. and try to wrap things up. So going back to the slides, there's much more than what we had covered in the deck in the last couple of minutes. So in the database engine, we have additional functionality, additional enhancements for grouping sets, which is just much richer functionality for the grouping clause in select statements. We are also improving our index view storage because now you can use index views in a partition-aligned fashion, so you don't need to drop and recreate your index views when you switch in or switch out partitions. We went ahead and separated date and time data types and made enhancements to locking as well. On the analysis services side of things, we now have functionality to trace your query workload. We improved the write-back performance. We added functionality for read-only scalable databases and also for resource monitoring. On the integration services side of things, now integration services support the Visual Studio tools for applications for scripting, and also the data flow thread allocation has been improved significantly. And those are all features that I didn't have time to cover in the previous slides. So I'd like to encourage you to go and check out the June CTP for SQL Server 2008. And yeah, look at the features, and please also send us feedback on how the different features work for you. That is, for us at this point, the most important thing, because we want to make sure that in the next couple of months development time, we really fine-tune the features in a way that they are most useful for you. And so this pretty much concludes my presentation at this point. Let me wrap up by summarizing the last 60 minutes. We had a look into the different features that are coming ahead in SQL Server 2008 that are related to data warehousing scenarios. You should get an idea of what you can expect in terms of performance and scale in the upcoming SQL Server release. And you should also be able to understand what is available in the June CTP, the latest community technology preview of SQL Server. You can check this out if you print out the slides or print them into a PDF document. I have little bubbles at the right-hand corner, at the upper right-hand corner of each slide. And if the feature is available in the CTP, it will say in a little bubble, available in CTP. And if some of those features catches your eye, again, I'd like to encourage you to download the CTP and give us feedback on what we can improve, where we can improve, and how we can make things work better for you. So thank you very much for your attention. And I'll go to the question and answer slide and fire up my question manager, and also while I answer the questions, also hand back to Heather, because she is going to explain to you how to fill out the survey and things like that. Is that correct, Heather?
Yes, that is correct, Torsten. Thank you very much. So I will go ahead and launch that slide now. You should be seeing it showing up in your slide area in just a moment. All you need to do to fill it out is click on the links that you see in the middle of your screen. We do appreciate your feedback. We read all your comments, so please do take a few moments to enter in that information. And also, Torsten mentioned that you can print a PDF of the slides. And to do that, you just go up to the File menu and select the Print PDF option. And with that, I'll go ahead and turn it back over to Torsten to address questions.
So the first question that I see here is from John, and he asks, does this version fix the memory bugs that prevent using large data sets in reporting services and serializing to .NET? I'm not quite sure what exactly John is hitting, but we are aware of a number of problems around scalability in reporting services, and I had this on one of my slides, where I just briefly mentioned that we are making scalability improvements to the reporting services engine. And again, I'd like you to check things out and download the CTPs and see whether the issues that you have been hitting in previous releases, whether they are resolved. We have taken some effort, quite some effort, to get to that end, and I'm very curious to see and learn how that works for you. So let me move on to the next question. When are you planning to release the next CTP for SQL 2008? It should be coming up in the next couple of weeks. Right now, we are basically closing down the work and performing testing over CTP 4. I don't want to promise an exact date, but it should get out in the beginning of August. So we are trying to get to a point where we can basically release CTPs every 2 months. And this is pretty much the schedule that we have in mind until we RTM SQL 2008, that you get a new CTP every 2 to 3 months. And yeah, this time is particularly interesting to us because a lot of the new and bigger features are coming in right now. So I'd like to encourage you to really look into the CTPs as they come out and check whether they cover the features that you're most curious about. And if that is the case, go ahead and install them and provide us with feedback. Wow. Then another question that I have here is, what's the row size on the quoted core tables? And I'm not quite sure whether I understand the question. The question is from Sasan. I'm having some trouble understanding what you mean by quoted core tables, and if you could just post a little bit refined question into the question manager that explains this, that would be great. So let me move ahead to a question from JD, and his question is: I can see merge being useful in slowly changing dimensions. Can you specify the columns that need to match, such as to exclude certain metadata fields like is current row? So thinking of the example, the syntax example that I had in my slides, the merge syntax, the statement comes with a merge target table using source table, and then an on clause that basically is the join predicate between the target and the source table. And all of those columns where you want to match on, those you would specify in this on clause that joins the target with the source table. And if you omit all the columns that you don't want to match on from that on clause, then you're fine, and you're not matching on metadata fields. So the next question down here is the comparison against SQL 2000 or SQL 2005. So all of the numbers that I showed on various charts along the presentation are against SQL 2005. So these are performance improvements over 2005. The next question is from Arun around change data capture. He would like to see a demonstration of that. Unfortunately, we are already over time, so I really cannot go into a demo of CDC. Also, CDC it's coming in with CTP 5. So right now we're besides a kind of internal builds that I could use here from the development team. There's nothing that I could demo on an officially released CTP. So I'd like to patient you on that front and wait for CTP 5, which will have change data capture. The next question here is: are you going to improve the XML load task in SSIS? It is very clunky to use. It's an interesting point. I'm not sure what specific enhancements we are trying to do at the XML load task in SSIS. So I'd like to take this offline and maybe find out more with Travis, and give me a minute. And yeah, Travis, maybe I should mention this on the overall call. If you have any questions, my email alias is torsteng@Microsoft. So please, if you could please drop me an email with this question again, and then I can reply back to you and check with the team what we are actually doing about the XML load task in SSIS. So just drop me an email. My alias is torsteng@microsoft.com again, and I'm happy to take care of that out of band. Now, here's a question from Mark. So Mark's question is that he wants to know more about reporting services being no longer dependent on IAS. So far, IAS was a requirement in 2005 in order to be able to install reporting services, and we are planning to remove that requirement for SQL 2008. And this is pretty much it. So just a limitation in terms of setup and install. The next question is around the release dates for CTP 5. So we are planning to release CTP 5 about 6 to 8 weeks from today. So we're expecting CTP 4 to come out in the next couple of weeks and just add 2 months onto that. And this is when we are planning to have CTP 5 out of the door. Now here's a question. Let me read the question. It's from Sasan. Let me read the question to you. I quoted a certain amount for the number of rows for a table size early in the presentation, and the question was how wide was the table and how many columns and what data types did we use in the table. So I'm not quite sure what particular example you're referring to. So I've had one example where we were talking about the testing effort for large-scale data warehouses, where we were talking about hundreds of billions of rows on the database engine side. And I can tell you a little bit more about the actual environment that we are performing those tests in. So a lot of those are based on the project real. If you go to www.microsoft.com/SQL, you will find information about Project Real, which was an effort that we already started in SQL 2005, where we teamed up with Barnes & Noble to get data sets and workloads from them. And we are continuing on that path, and we are scaling things based on this Project Real workload to the numbers that I quoted in the beginning. So I don't have the schema of the table right in front of me, but it pretty much reflects a schema that, for instance, a book vendor such as Barnes & Noble could use to do a data warehouse on. So it's based on that Project Real, and again, you can find more information about Project Real on the Microsoft SQL Server web page. I hope that answers the question. ProClarity, the next question is around ProClarity, whether it will be integrated in SQL Server 2008 or not. From the top of my head, I really, frankly, don't know the answer to the question. Again, I can find out for you, and if you want to drop me an email with a question, again, my alias is torsteng@microsoft.com. I can find out and try to answer your question offline. And how will authentication work in SQL 2008 if there will be no dependency on IAS? Is the next question. Again, I'd encourage you to send me that question through email. I quite frankly, don't know the answer at this point in time, and I would need to ask someone from the team. Yeah, I'm seeing quite a bunch of reporting services questions down here. Again, let me encourage folks, because we are running out of time. Let me encourage folks to send me further questions offline. Again, my alias torsteng@microsoft.com, and yeah. So this is pretty much all that I have at this point in questions. So thanks very much for joining us today, and let me wrap up the call and close the questions session and hand things over back to Heather.
to wrap up the call. Thanks very much again for joining us today.
Thank you so much, Torsten, for your presentation today. I'd like to remind everyone to take a moment to fill out the survey prior to exiting the session room. Thank you all for joining us. You may now disconnect from the audio portion of today's conference.